So at this point in the program, I'm sure that you've come across at least one example of a very commonly tested MCAT question. And that type is where they include, for example, a graph or a story problem, giving you information about, let's say, velocity versus time. And then what they'll ask you for is to interpret or identify a graph of acceleration versus time based on the information they provided, or determine the graph of displacement versus time based on the information provided. These questions can be very tricky and very hard to work out. So what I'm going to do is I'm going to show you a basic trick that can help narrow down the options for you and simplify these tough questions. So let's see how this trick applies to the types of questions where you'll be asked to relate acceleration, velocity, and displacement to one another. Okay? So let's go ahead and start off with this graph on the far right, and let's say that this graph is a graph of acceleration versus time. If that's the case, then notice that our acceleration is not only constant, but it is a constant zero value. Now if our acceleration is zero, then that means that there is no change in velocity. If there's no change in velocity, then this would be an accurate graph of our velocity versus time. So if this is a graph of velocity versus time, then you can see that our velocity is constant over time due to our zero acceleration. Now if this is our graph of velocity, then this is going to be the graph of displacement, because you can see that our velocity is constant over time, which means our displacement will be constantly changing. In this case, constantly increasing, because you can see that our velocity is a positive value. But now we can change it up, and let's say that this second graph is actually our graph of acceleration versus time. If that's the case, then our acceleration is a positive constant value, which means that our velocity versus time should be constantly increasing. Now if our velocity is constantly increasing, then our displacement should be increasing at an increasing rate. And you can see that in this exponential graph at the very end. So keep that in mind. So all of these relationships work out nearly perfectly every time. Now one thing you want to be very careful of with these graphs is that you can never do them in the reverse order. For example, you can never go acceleration, velocity, displacement that way. It can only work acceleration, velocity, displacement the way I was showing you earlier. In addition, you can never mix and match the variables. For example, you can't do acceleration, displacement, velocity. It doesn't work that way. It only works in the order I first showed you. Now don't completely depend on this as a crutch, because this trick doesn't perfectly apply in all situations, because this trick really depends on the values. For example, let's say that rather than having a positive acceleration up here, we actually had a negative acceleration for a projectile. In that case, this would not be an accurate graph of our velocity versus time, right? But it would be very similar. In this case, our velocity versus time would simply be increasing in the negative direction rather than in the positive direction, right? Or if we were starting with a positive velocity, then our graph would be decreasing towards zero at a constant rate. Okay? So just be careful. These graphs do work in every situation, but you just have to be careful about the signs and change perhaps the direction or the value of the graph depending on those signs. But if you do keep these four graphs in mind and just draw them up at the top of your scratch sheet of paper at the beginning of the test, these will serve as an excellent reminder and an excellent trick to help you more quickly and more accurately solve the problems. I personally use these to check my work after I've solved for the problems conceptually, or to simplify my conceptual understanding of the problem.